Hello, students. This is Mr. Gibbings here. So I am stuck at home isolating because I was in contact with somebody who was in contact with somebody, and so anyway, we're gonna do our lesson. So rust is a problem. Here's the problem: iron rusts. That really means iron dissolves, and that's expensive. Your fancy gate dissolves, your car dissolves, bridges dissolve. Anything made out of iron will eventually dissolve and rust away. So that's expensive. You got to replace those things. Even the Eiffel Tower. I've actually been there a couple times. It's pretty cool. But even the Eiffel Tower can rust. A little bit of trivia. It was built for the World's Fair in 1889. It was not meant to stay there, but then it stayed. It wasn't meant to be a permanent thing, but it was kind of a cool looking building, or structure, so they kept it. Its purpose in the World's Fair was to demonstrate the usefulness of iron as a building material. Today, if we were to open up the ceiling panels in the roof above you in the classroom right now, we'd see all kinds of iron up there. Up until then, in 1889, iron was not used widely in construction. So this was built to prove that, hey, look at the cool things you can build with iron. Anyway, then it was used as a radio tower. And one more piece of trivia. Right before the Nazis invaded, the French actually cut the lines on the elevator cables so that if Hitler wanted to climb to the top of the Eiffel Tower, he was going to dang well have to walk up. So take that. All right, question. Why hasn't the Eiffel Tower rusted? It's like over 100 years old. So there's the Eiffel Tower. Still looks pretty good shape. And there's an old train bridge. So why hasn't it rusted? The simple answer is paint. So they actually paint the Eiffel Tower every 7 years. Because of its value as a tourist attraction, the Eiffel Tower is painted every 7 years to protect it from rusting. So that's probably a pretty big job. Somebody gets paid a lot of money to go do that, I suppose. Anyway, it needs to be painted every 7 years. So what actually causes rust? Well, water reacts spontaneously with iron, right? So if you just stick your car outside, drive through a puddle, it's going to start rusting, right? Well, actually, no. If you just go iron plus water, or water plus iron, Fe, nothing actually happens. No reaction actually takes place. So, the rust reaction isn't water plus iron. This is what it is. It's actually oxygen and water and iron. When that reaction happens, you actually get those products. And notice that the iron is solid over there, which makes sense. Your car is something that's solid. You can see it. But on the other side, the iron has an aqueous symbol. And aqueous means dissolved in water. So the Fe element has become this Fe2 positive ion. It just means it's a piece of iron that lost 2 electrons. But when it does that, it becomes aqueous. So iron is actually dissolving. So that's the rust reaction. There it is. O2 plus 2 H2Os plus 2 irons makes 4 hydroxide ions and 2 iron 2 ions that are dissolved in water. So water plus oxygen reacts spontaneously with iron. Now the rust reaction is actually more complicated. It's actually 3 reactions that happen one after the other. So there's the first reaction that happens. So you got a piece of iron, you got some water on it, you got some oxygen, and then the iron, also I'll show those 2 little irons right there, actually gives some electrons to the oxygen. And when that happens, we get these things called anodes and cathodes, which I'll explain in a second. We make 4 hydroxide ions, so just these things dissolved in water. And the iron actually dissolves and becomes aqueous. So we get a little bit of a hole there where the iron has started to dissolve. And it Fe solid turns into those Fe2 positive aqueuses. And then those iron 2 positives react again and turn into iron 3 positive. And then iron 3 positive reacts again and turns into this Fe2O3 iron oxide with 10 little waters attached to it. It's called a hydrated compound. It's a precipitate, it's a solid, and that's what we see as that little red stuff on rust, or on a piece of metal that has rusted. Do you have to know all of that for this course? No. You just need to know the top one, and just the basic concept that it's oxygen and water, and Fe solid becomes aqueous. That's what you need to know. Okay, so here's a simpler way to look at it. There's our air, there's our water, there's our iron. And it just happens that we make a little hole, and we get a little bit of a precipitate form. It's called a precipitate, a solid, rust. So how do we protect iron from rusting? What could we do to protect it? Well, what did we do to the Eiffel Tower? Oh yeah, we painted it. So if I take my little paintbrush and I paint a layer of paint over top of the iron, I get a drop of water on there, and now the water does not touch the iron. It's sealed by this layer. So paint acts as a boundary that separates the iron from the oxygen and the water. It's like paint takes away the plus sign right there. It's like the plus sign disappears. The water and the oxygen are no longer touching the iron. And if that happens, the reaction does not happen. If they don't touch, they don't react. All right, now this part here is going to look really confusing. I just copied it from my Chemistry 30 stuff, but there's our reaction. We already have talked about that. How else can we protect iron from rusting other than painting it? Well, here's what we can do. What if we stuck another piece of metal on it? So we're going to stick some magnesium on it. Now, our course doesn't have to cover this, but magnesium actually reacts quicker than iron does with oxygen and water. So what happens is oxygen and water actually don't react with iron. They react with magnesium. And it's the magnesium that begins to corrode. So what we see here is, you don't have to worry about that stuff. What we see is the drop of water touches the iron and the magnesium at the same time, and it's the magnesium that begins to corrode. So the purpose of this is, if you take some inexpensive cheap metals like magnesium and attach them to iron and space them out, and it'll protect the iron from rusting. These things are actually called anodes, and we sacrifice them. They're called sacrificial anodes, and they protect the main structure, which is called the cathode. Anyway, that's what you need to know. There are other metals that are less expensive that we can stick onto the metal, iron, and it will corrode and protect the iron. So that's called cathodic protection, but you just need to know sacrificial anodes. So what are some examples of this? So you actually have this in your house. You got a water tank, and inside is a sacrificial anode. And you can take that out. Look at the one on the top is a brand new one. The one on the bottom has corroded. It corrodes instead of your tank. If your tank starts rusting away, it'll get holes in it and leak. Well, why not put a cheap metal inside there that will rust instead? So there's a plumber who has taken out an old rusty one, and he's going to put in a new sacrificial anode. You actually have these on boats as well. Those rectangular blocks that are on the bottom of that boat there, those are called anodes. They screw those on, and those corrode instead of the iron boat. There they are again. You can see them spaced and dotted all over the bottom of that boat. Smaller boats like you might buy for fishing and water skiing, those rectangles there are anodes. There's a sacrificial anode right there. There's one that's new and there's one that's been corroded. So it's better that that corrodes than your boat, right? So there's another way we can protect iron, and it's through this process called galvanizing. So we take an iron nail. Now if you just take an iron nail and chuck it in the water and it's exposed to oxygen, it's just going to start rusting. We'll do this when I get back to class. We'll do the experiment. So if we take another iron nail and we drop that into molten zinc, in other words, we've got this tub of zinc that we've heated up and it's melted, it's turned into liquid, and we drop the nail in and bring it out. That's called a galvanized nail. So the iron has a layer of zinc over top of it, and that acts just like a sacrificial anode. The zinc corrodes and protects the iron inside of it. And so when you see the guys building houses and they have these, what they call them, hot dipped nails. Hot dipped is that molten zinc bath. Hot bath where they've coated the nail with zinc. Anyway, they use those because those are exposed to the outside air, the nails in your house, and they don't react nearly as bad as just an iron nail. Eventually they rust, but not nearly as quickly because the zinc all has to corrode first and then the iron starts. So it's like an extra layer of protection. Okay, that's it. The lesson is over and you can do your assignment. Okay, thanks for watching. Bye-bye.